form of matter, that is liquid, and understand more about it. When we add sugar or salt in the water, it dissolves, right? Why is it so? We already know that molecules in the liquid are loosely packed, so there is space between the molecules of the liquid water, and within this space, the molecules of sugar or salt fit in when mixed with the water. The substances which dissolve in the liquid are called solute. So sugar and salt are solutes. The liquid in which the substance or solute is dissolved is called a solvent. So water is a solvent, and when a solute is dissolved in a solvent, it is called a solution. So when we dissolve salt in water, we get salt and water solution. Can gases also dissolve in water? Let us see. How do aquatic plants get air to make their food? Or how do aquatic animals like fish breathe? Yes, some gases like oxygen and carbon dioxide dissolve in water, and that is why aquatic plants get their carbon dioxide for photosynthesis, or aquatic animals get oxygen for their breathing. Let us talk about another example. When you open a bottle of a fizzy cold drink, do you know what is that fizz? It is carbon dioxide dissolved in the cold drink, which comes out when you open the bottle. Can two liquids also dissolve in each other? If you pour some alcohol in water, alcohol will dissolve completely in water. So some liquids can dissolve in each other like water and alcohol. But try pouring a spoonful of oil in the water and mix it. What happens? The oil floats on the surface of water. That is, it does not dissolve in the water. Liquids like water and alcohol that dissolve in are called miscible liquids. So water and alcohol are miscible liquids. Liquids that does not dissolve in each other are called immiscible liquids. So water and oil are immiscible liquids. Have you wondered why do some substances float while some others sink in water? For example, a big ship can float in water. But if you just put a small iron piece in water or a stone, it sinks. How is it possible? Let us look at this in detail. When something is balancing on top of the water, we say it is floating. If it goes under the water, we say it has sunk. Let us understand this in detail. Whenever a body is immersed in liquid downwards, it experiences a force from that liquid in opposite, that is upwards direction. For example, this bottle is immersed in water. The water has a pressure that pushes up the bottle. If the water's upward push is greater than the bottle's weight, the bottle will float because the water pushes the object up. If the bottle is heavier than the water's thrust, the bottle will sink. What happens when we put some object in water? The water rises, right? And sometimes it goes over the side, that is, it overflows. This is because the object displaced some of the water with its body, and the water had to go somewhere. Correct? If the weight of that object is more than the weight of the displaced water, the object sinks. If the weight of the object is equal to the weight of the displaced water, the object floats but remains completely immersed in the water. And if the weight of the object is less than the weight of the displaced water, it floats on the water. The key to floating is that the object must displace an amount of water which is equal to or more than its own weight. The main thing to remember is that whether an object can float or sink in the water is not dependent on its size or weight, but on how much water it displaces. Let us assume there is a steel ball and a bowl of steel, both of the same weight. Now put both of them in water. What do we see? The steel ball sinks, but the bowl of steel keeps floating on the water. Let us see what exactly happened here. When a body is immersed in water, it displaces some water, and hence it experiences an upward force. This upward force is equal to the weight of the water displaced by the body. Here, the steel ball is unable to displace water that equals its weight, so the steel ball sinks. But when the steel of the same weight but shaped as a big bowl, its weight gets distributed over a larger area, and hence the steel ball displaces water more than its weight, so it floats on the water. The upward force is known as the buoyancy force, and this theory is known as Archimedes' principle. This phenomena was accidentally discovered by the Greek inventor and mathematician Archimedes. Isn't it interesting? Without this, can you imagine we would have built big ships that carry a large number of passengers and material from one place to another? Now let us find it mathematically. Let's assume the weight of the steel ball in the air is 7 kgs. Now immerse the steel ball in the water. Its weight is shown as 5 kgs. That is lesser. How? This is because the buoyant force of water acts upon this steel ball. The weight of the steel ball in air is its actual weight, that is 7 kgs. The weight of the steel ball inside water is its apparent weight, that is 5 kg. And in this example, which is more, the actual weight or the apparent weight? Yes, the actual weight, that is 7 kgs, is more. The apparent weight is known as apparent loss of weight. So we can now say the weight of water displaced by this steel ball is equal to the apparent loss of the weight suffered by the steel ball. That is 7 minus 5 equal to 2 kgs is the weight of the water displaced. And because the actual weight is 7 kgs and the weight of the water displaced is 2 kg, the steel ball sinks. Now take the steel bowl and repeat the same exercise. Its weight in the air is 7 kgs, that is its actual weight. Let us put the steel bowl in water. It displaces more water because it's larger in volume. Now see its apparent weight. It's 0 because the amount of water displaced is 7 kgs or possibly more. Hence, the steel ball doesn't sink and keeps floating in water. So, apparent weight is the change in weight of an object, and it happens due to a force exerted by the surface on which the object rests, like water in this example. So, the object is trying to go down, but the force of water is trying to keep pushing it up. So, the weight of the object reduces. The reverse can also happen. Let's say an object is going up in the elevator. So a force will push it down. So object will feel heavier when it is going up. That is, its apparent weight will increase. So next time you go in a lift, keep a weighing scale and weigh yourself when you go up. You will see your weight increasing. Bye bye children.